Welcome. Oh, sorry, you're supposed to talk first.
What were we supposed to say?
I don't remember. Welcome.
Well, Ben, what are we doing today?
Today we're talking about the state pattern.
I figured out what we can do. This is like Phineas and Ferb.
What you doing? Jared, I know what we're going to do today.
That's right. What are we going to do today?
We're going to talk about the state pattern. This is another one of the classical patterns out of the Gang of Five book, which I think I've seen referenced somewhere, the Goff book. G, big G, little O, big F. So we're just going to call this is one of the Goff patterns, can be found on page 305. And this is another one that we use a lot.
A lot.
Yeah, maybe not. What was the one we did last time? Observer. Not
Observer.
quite as much as we do Observer, but like the Observer, this pattern will save your bacon if you use it right.
Well, guess what? The future uses the state machine. Has to.
It does.
Yeah,
That's
I'm trying to think if the observer does or not. I can't remember that.
I think there are states in there.
Anyways, it's pretty much.
There are, because you can start and stop the observer.
That's
that
correct.
Changes the state.
So there are state machines
Inside.
of the observer. So I
Our
would argue.
interpretation yeah, that's true. This shows up everywhere,
It does.
especially in UI programming. It seems to crop up a lot.
Yep.
Okay.
So why would we need the state pattern then?
If you have an object that its behavior is going to depend on the internal state of the object, then each state of the object that you want to deal with, it's good to represent with another internal object for that object. So when something comes through the object, then
Okay, let's start
I'm going to
this.
draw a picture.
Well, before you go there, let's state how did they come to the solution? Because there's a problem first, right?
Yes.
I think maybe we should discuss the problem
And
first.
what is the problem?
The problem is this. Let's say you have two methods. Let's keep it simple.
Okay.
Let's do three methods. So you have method one, and let's say you depend on a state. So you save your state up here with maybe a string.
And this state would be something like...
Let's just state one.
Okay.
Or state what? State
active,
active. Let's do that.
inactive, or in
Start,
transition.
stop. There we go. Transition. Start, transition, end, maybe.
Yeah, okay, we'll pretend that we have a ball here, and the ball can either be here, or here,
Or somewhere in between.
on its way in between. So we have left, right, and transition.
Perfect. So the problem starts with this. If you're telling the ball to start, your interface on your object doesn't change. It doesn't just drop off the start method. It means that people can keep calling start,
Okay,
right?
let's do this. Let's say that the ball is right here on the left side.
Correct.
And I say, hey ball, go right. Or,
Right.
No, I say, hey ball, move.
Okay, move. That sounds good.
Alright. Ball, move. Let's write.
Okay, so we have a move function. So now this move function is going to say, hey, my state is now equal to moving, right?
Yes.
And, wait, no, hold, it's not. It's not that easy. Well, should we start from the...
Well, let's pretend this is the only state for now.
Okay.
We'll illustrate the problem.
Okay. Equals idle, I guess.
We call it left.
Left.
Because we have left, right, and moving.
Okay, left it is. Okay.
Okay,
Now, what do I do?
so this is going to say even... Let's do this.
Okay. How many...
This is how it actually works during the day.
Yeah, that's exactly how you write code, huh?
He'll write something and I'll erase it. So the ball's over here. I want it to move over there, and so now we'll say ball dot go right.
There you go.
And then, okay, the ball is going to start heading that way.
Maybe we should go right. Yeah, anyway, go right. That sounds good enough. Good enough. We're good.
Okay.
Yeah.
Now the ball the ball shows up over here. The ball moves over, so now it's there.
Right.
But I want it to move back, so I'm going to say, hey, call this move function. And the move function is going to say, hey, ball, go right.
Uh-oh, we got a problem.
That's not correct. We need to go left. So, okay, it's time.
Oh, this is great.
It's time for an if.
Uh-oh, here comes the big nasties.
If state equals left.
Oh, this is so good.
Well, move right. Our ball is named B now. Else B dot move left. Phew. Alright, now we're saved. Ball, move. Oh, I forgot something. We need to keep track of this.
Yeah.
We're gonna move right and say the state
Yeah, your state machine would have been
equals-
horrible.
right. And then we'll say state equals left. Okay, now this works. I can say ball move, and if it's over here on the right side, it'll jump over here. And if it's over there, then it'll go over there.
Perfect.
But it actually takes about 3 seconds for the ball to get from here to here.
Uh-oh, now we got another state.
Wait. Now,
This is not good.
we're gonna have, gotta get rid of all this stuff. If state is left, B dot move, oh, well, I'm not even gonna do that yet. State equals transition, B dot move left.
Uh-oh, you gotta move right on that one. See, you already got
Oh,
confused.
you're right. Move right.
We're already getting confused here.
It's going to take a little while. The ball will let me know when it's done, so I'm going to say then. A couple videos ago, we talked about
Futures.
futures and promises. Now my ball's in the way. Then, shorthand function. Anyway, you get the drift, right?
It's getting started. And that's only with one function, by the way.
And then once it's all done, we'll say state equals right. Now we have to have another if for right.
Right.
If right, if transition, and inside each of these, and you can see how that's going to become a big mess.
And it gets uglier and uglier. Let's say that something else in our object, I don't know what we would do that would have this, but it needed to know its state as well. So let's say that in transition, it couldn't jump or something like that. It couldn't bounce. So if we had another method down here called bounce, it would then have to do all of this garbage
Inside the bounce method, yeah.
again.
For everything that this object can do, we're ending up having to take this big old nasty if and move it around. And for every state that we add,
Yes.
that's a maintenance point for every state.
Method.
So it's like states times methods.
Yep.
And it's really unmanageable.
And then you can't. What's really hard is you do exactly what he just did. He goes, you write this and you're like, oh, the state equals left. That looks right. And then you forget that this is actually really the problem. You put left right here, right? Good luck debugging that one, because it's all tangled because there is a right somewhere in this method, and it should move right somewhere in this method, but your mind gets tangled in a knot trying to understand where the heck it is in its life, and you don't know where it's at, and it's impossible to debug. Well, it's not impossible to debug, it's just impossible to understand.
It is really hard to maintain. So a couple of things should jump out at you here. First, that we're reusing these conditionals over and over again per method.
True.
So that's a reuse violation, right?
Right.
And there's another violation here too, and I don't remember
Oh,
exactly what it is.
I was trying to think, what was that, I thought I had I could remember a video that talked about this, but I can't remember it now. Anyways,
Yeah.
it doesn't matter. I'll think of it sometime.
Anyway, this is the problem, and you can see how it can become a big problem.
All right, so let's go to where you were before I interrupted you.
Okay.
Someone's gonna start screaming at me, "Let Ben talk!" Okay, will do. Ben talk.
We were thinking of examples to demonstrate this, and came up with a really good one. Better make this pretty big.
Yeah.
This is like the grandparents' model.
We've all seen these controllers that size.
So you go out and you buy a TV and a Blu-ray player and
Radio.
VCR, because you still got one of those,
Okay.
and a radio and a tape deck and a CD player. And
Woo!
instead of keeping all of these remotes around the house, you're a programmer and you're always looking for strategies for reusing things. And you notice that these have a lot in common. So you're going to refactor all of your individual remotes into a fancy bought from Radio Shack for $20 universal remote.
That's right.
And it's got all of the stuff that a remote should have, buttons that do numbers.
And arrows like the menu thing.
And then, yes, the arrow.
There
thing.
you go.
And then it's got a bunch of little buttons down here that you never use. And
Oh.
you're really not quite sure what they're for.
They're just buttons.
And then there's the random button up here that does something that your TV can't. But up here at the top, generally at the top,
That's right.
there are some buttons, and they let you select what you're going to control. So this one might be TV, radio, that says radio,
Yep, okay.
VCR, DVD. This is a state machine
At its best.
at its best. I mean, it's pretty obvious. I
Did
mean,
he-
you know how this works.
You actually said something that was interesting. You're like, and these buttons that your TV can't do, well, that's just it. That state just goes, I'm not going to throw an error, I'm just going to not do anything.
Your remote doesn't blow up when you hit one.
You're right. Doesn't start your TV on fire. Doesn't throw an error. It just doesn't do anything. So let's go
Your
ahead.
house doesn't have a seg fault or anything. Yeah, this is a state machine. So what is actually happening here is you've got electronics enthusiasts, forgive me.
Yeah, I didn't understand any of this.
You've got this is up here is a little IR LED, and this is, I think, the symbol for
Represents a
an
very.
LED.
You're gonna kick yourself for years if that's not right.
I know, my brother's gonna kill me. Anyway, this is the part of the remote that makes the signal. So it's gonna shout out to the world a number.
Right.
And that is connected to something that makes a number. And that is connected to something that decides which
That
number
tells
to
the
make.
number to make. Yeah.
So you can picture this as your keypad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Oh, that's a beautiful keypad.
So when you push one of these buttons, what's inside here needs to change. So you can imagine a different little brain for each one of the states of your remote.
You know what this is like? I'm gonna add to you right here. This is like one of those reels where you can like send it through and it stops at the right one.
Oh
So you
yeah.
pull it. Anyways, go ahead and continue on.
R, and then we'll put the DVD in here right now.
There you go.
So when you push the TV button, your remote inside is
Right.
gonna take
You
this,
get down.
pull that down, and then all this moves until the TV is in here. And now you push the button, it goes through the TV brain, and then out spits the number. And then you push the VCR button, because you do that frequently, I'm sure. And then there's the VCR. And that is a state machine.
And what's so awesome is when you start thinking of state machines like this, you actually visualize your program like this. I'm always thinking of things. I'm like, what? Where am I on this thing that's
Yeah.
supposed to tell the thing? That's anyways. That was a pretty bad thing and thing. And they had a word in the Philippines called Kwan that meant anything you wanted it to. And Kwan. Anyways, this is gorgeous though, because then you know, hey, I'm messing with this state. So how do we program this? we understand the concept now. Pretty awesome.
We program it usually by watching Jared do it. So
I love state machines. And I have another way. He gave a great visual, but this is how I visualize it in my mind when I'm programming it. Because programmers love squares. I went to an artist friend's house the other day. He's like, why do you guys always use squares? Just make a circle for me. I couldn't. I just couldn't. I don't know why. But anyways.
And keep in mind real quick that these state machines are usually something that you put inside of another object. So this would be like our remote program has a state machine inside. It's not something that's generally exposed.
Correct. It's only exposed to the interface that the controller, for example, the controller itself has an interface, right? The interface has like the power button, right? So let's just do a few. Power click, let's say that. And then click or push. It's not click, it's a push. All right. Power push, and then let's do 1 push, 2 push, etc. Let's just do that many. So as you can tell, you can see how complicated that controller could get. Like, can you imagine writing that universal controller for every possibility with an if statement? And you've got how many buttons on there? Like 100?
And then the book that comes with it for all the codes that you
Oh my gosh. It would be a nightmare. So.
Not even a switch statement would save you.
No, that would. That made me twitch a little bit. So what happens is you need one more thing in here, and it's like before we were saying you need something that stores the state. This is private though, so let's put this kind of over here. Okay. And matter of fact, what I'm going to do is I'm going to say we have a special slot for the state that's down here. So this is kind of like a pointer, so to speak, like the tags that we talked about in one of our videos. And this state interface is expecting to have all of the options of up above. So we'll say 1 push and then 2 push. Well, didn't we have 4? So we had 4 states. So that when you're writing this, what's really neat is all you have to worry about is like how many different states do I have, and then you don't care about. I remember it's when people get confused about which state they're in. It's like, don't think about the other states. Just think about the state that you're on. So we have power state, right? So we're going to say, okay, I have a power state. This is what's cool. This is a good one. So the power state would be the off. We'll just say off state, basically.
So are we talking about the
not
remote
power
or
state.
the
I'm
TV?
sorry, the TV. We're going to need to do TV state. So TV state. Thank you.
That's a good point though, because in
That's
the
actually
TV,
states. There's another
there is
states.
actually another state machine because the TV says, "Am I on?" Then I should turn off.
Thank you for.
Am I off? I should turn on.
Exactly, and you should do that because what happens is all those methods that you're in, right? The 26 that are on the controller, you have to do an if on, do this, if else, don't do anything. So.
And when your TV is off, you can pound away on all the other buttons that you want. The TV might be hearing those. In fact, it is, because it has to be listening for the on button.
Correct.
But there's like all of these functions for all of these buttons that just map to
an empty function.
a black hole. It's like 1 does nothing. 2, that also does nothing. 3, also nothing.
You'll notice like in our base libraries, we have this thing often up on the top called empty function. Because I found myself just writing empty functions so much. It's like, we should probably consolidate that and not have to create so many functions.
And that saved us 5 characters per empty function.
But it said a lot because we then knew that it just consumed it. It's like a nullable object, in other words. So thank you for catching that state. There is another state inside this state, but
that's
use your
on the
imagination.
TV. We're dealing with the controller.
That's correct. So we have the power button, power push, right? 1 push and 2 push. VCR. What was the other one?
DVD.
DVD. I can't remember. You'll have to use your imagination.
Fair.
All of these, though, have to. I'm doing that so you can tell that it's a header. All of these states have the same functions or the interface as your controller does. So what the controller does is it doesn't think about doing anything special in here. It doesn't even govern the state unless the buttons of TV, right? When you push the TV, it goes state equals. So let's do that actually. So change state or something, right? Change state, and you pass in the change state to TV is what I would do. I don't like to pass something in through TV. All right. So what that method would do is then say, hey state, you're connected to here. So then when this method's called, the power push or one push, it goes, hey state, inside of its method, I need to call your one push. So then it calls that method, right? Well then the user clicks another thing, this gets detached from the state machine, and it says, oh, the user clicked on DVD, so now this goes to here, and now this is calling this power state, or power push. It's so awesome. And there's one thing that there's lots of examples of this. It's in the future, it's in Observer. We had a change tracker in our data context we used it on. It just makes all the difference. Because you just think about, what do I do? So instead of the power push, well the power push is a bad one, but let's go push one on the DVD. If I care about something, then I do something. And if you can't respond to that crazy button, you just have an empty function. It doesn't break the controller. It doesn't do anything. It just goes, nothing, not going to even send anything out because I can't do anything.
What this really allows you to do as a designer is think about your object as, it's actually like 6 or 7 different objects inside the object.
Yeah.
So with the if statement, you're thinking in the context of states. So if state, if state, if state, if state. With the state machine, that lets you think about your object in the context of the state that's in and forget about everything else.
You don't see ifs. I'm very few ifs in the state machine if they're done correctly.
Yeah.
Like inside these states. Because all you do is you plow through a straight line of instructions. You know how we did the what and how video? It's basically just a bunch of what's being, I need to do this, I need to do this, I need to do this.
Yeah.
And filling out the how of the method. But anyways, it makes the ifs disappear and your code is now readable because you know exactly what you do. Oh, and that was the other thing we didn't discuss. When you do an if statement, right? You said if this state, you can have additional code at the bottom. Good luck debugging that one too. Because if there's any code outside those ifs, it affects all of the states. That gets really messy. And you're not sure if it affected it here or if it affected inside the ifs. This you know, hey, the bug is not in here because I can read through it all and it's doing exactly everything right, so it must be back on the controller. They're just trying to do too much.
You can always ask your object, what state are you in?
Yep.
With the if statement, you actually run the risk of your object being in limbo 2 states at once maybe. Maybe your state flag got thrown off, or maybe some code down here changes the state flag somewhere between an operation, so you could be in 2 states at once.
Between the if statement.
Yeah. So abstracting it out helps save you from that. Should we write one in JavaScript real quick?
Yeah, let's do it.
There's a couple caveats in JavaScript that always throw me off when we're doing state machines.
What are those caveats?
You have to have your state. I always mess up the current state holder object.
Oh yeah.
And end up skipping a step.
And it doesn't have a state at all? Is that what happens?
Yeah. Okay, so let's say
I usually even build all these state objects. A lot of times the state objects are built right inside the constructor of the, if they're really big I'll class them out, but a lot of times they're just object literals that resemble the outer interface.
and then
There we
we'll
go, that's
have
good.
they're gonna be this.
Yeah. So should I draw state 2?
Yeah.
Okay. So you're doing class of state 1, apparently, right?
Yes.
Okay, I'll do var class. Var state.
Oh, no, I did that wrong. The state is not a function. The state is an object.
Okay, I see. We're inside the constructor then. Is that what you're saying?
Yeah.
I'm confused. Okay. I'm confused, but go ahead.
Okay, so this thing can open.
Okay, good. I see what you're saying. So you're defining the default state is what you're defining. It looks like.
And it can close.
Oh, I see. I'm not sure if we can see this. Let's see where.
And then we'll have our
Yeah.
state 2 equals.
Boy, if we could program like this every day,
Now,
that'd be awesome.
what we really need is a whiteboard that compiles.
That's right. Right? So now
Yeah.
this controller would have a. Is that? Should we just do two states?
Yeah, let's do.
And then we'll say self dot open equals a function. Didn't take any parameters down. All we have to do here is we have one more variable we need. Where are we going to put it? Can't fit it anywhere. We'll say var current state equals, which one? State 1?
Yeah.
State 1. So now we come down here, and in this function all we have to do is say current state. Oh, return. You'll want to do that. Return
Yeah.
current state dot open.
Actually, let's make this a little more obvious. I'm going to rename these.
Okay.
Say state open
Oh, there we go.
and state closed.
Perfect.
And now our default state
Will be state
will
closed.
be, yeah, state closed. You have the blue one.
Okay. Then we need, the current state. Then you have another one down here, self. I'm not sure if this is even on the close, is equal to a function. It gets really easy at this point when you're writing the outer class. You don't even think. There's like current state, whatever the other states were, and I'm done. So you'd return current state dot close. Oh, there you go. That's a good one. This is where the inner states, after they do their closing, they can then change the current state to a state closed, and we're good.
And then, let's see, we're closed, so.
Yeah.
This one will say current state equals
Versus
state
code.
open.
Go ahead. I'll say something after you're done.
Okay, and these would not be one-liners.
Yeah, that's what I'm saying. So there would be a lot of code here closing it, and a lot of code here opening it, but then you'd be setting the state. And we do this a lot. A good example of this is in our future. When the state gets, it says the default state means it's ready, it hasn't been launched yet, hasn't been sent out to retrieve the value, but it's just waiting.
Mm-hmm.
And when if someone finally says get on it through various ways, like if someone says then or someone says if error, if anybody's interested in it, it sends it off.
Mm-hmm.
And at that point, when it sends it off, it fires the retrieve the stuff. And it goes and says, oh, by the way, now that we're retrieving the stuff, the state is retrieving, and here's what I have to do. And then at the very end of that, it does a callback and sets its state when it's got it back. So it sets it to retrieving. Then when it gets its stuff back, it says, hey, we've got it, but it's changing states in between there.
And because it's in different states, that call to then does a different thing
Every time.
in each of those 3 different states.
So the awesome part about this is when the then, on the finish, the complete, it doesn't even care what the others were, it just calls the callback right away. Because it knows it's done. There's no sense, it has its value, there's no sense in waiting around. Just,
Mhm.
here you go. That thing has already been fulfilled, and here's the value.
Yeah.
So there's a good example, and that's a pretty simple case. But when you're doing even what's it called, interface stuff, especially the animation, you should try using this. Your life will be a lot easier.
So to use this, we can say c.open, and it's going to open. When that happens, we'll say c.open,
Correct.
and then it'll run current state.open. And the current state happens to be closed
Closed.
state, so we're going to go here and run this open, which reassigns
The state.
the state to that one. So now we are in.
Yeah, then it runs that jazz, right? So now we're here. Now do c.open again. Just because someone was really crazy. Now it just does nothing. Empty function.
We're going to come down here. C.open is return the current state. We're not actually going to call it. We're just going to return it. Oh, I
No,
guess
you
you
call
could.
it. No, you call it. That's what you do.
Okay,
You
yeah,
call
that's right. All right, fine.
You call it.
Invoke it.
Sometimes, a lot of times we actually just do apply. I think that's what you're thinking because at times you don't want to have to remember all these arguments. I'm lazy that way. So I'll say
Oh, that's
open.apply or open.call because we'll apply so I can just send the arguments in. But in this case
Yeah.
it's just empty, so we call it.
Anyway, the current state is closed. No, sorry, the current state is open, so we'll run this function, which just does absolutely nothing. And there's no errors, there's no unexplained behavior, there's no what's
If
going
checks.
on. There's not an if in this whole thing, actually.
There's not.
And that's pretty nice.
We have, I do have a JS Fiddle. I had a challenge, I can't remember who it was by. Someone challenged me to do a calculator with no ifs because they said it's impossible. I think I saw it on Stack Overflow. They said they've been challenged and they wanted some people to tell them how to do it. And everyone's like, that's impossible, you need ifs and all this other control flow. Well, so I was like, no, I can do this with a state machine. Sure enough, the whole thing ran off of a state machine, not one if in the whole program.
You do actually use jQuery, which itself has some conditionals. But
Okay, that's true, but that was with the UI.
in the calculator itself, the
Yeah.
actual calculator logic uses no ifs, and it can multiply, add, subtract, and divide.
And do it stacking, or
Oh yeah, you
Like,
can
continue.
keep
Anyways,
going. It's pretty cool. Try it.
that's the challenge, I guess, right?
Yeah, you'll be amazed. It is possible. Anything else?
And a key to that from the
Oh.
calculator
Yes, something else.
is you need to, the states happen to be around the operators.
The operators.
So once you realize that the states are operators, your life opens up.
So if the state is operators, what do you start out? What state do you start out in?
There's one more state other than the operators, and that's the input state. I'm pretty sure.
That's all you need to know. 5 states.
Yeah.
Really?
Because it knows what to do when those numbers are pushed, and then it calls for a recalculate and changes the state back to what was pushed. Anyways, I challenge you to go try it.
Yeah.
Anything else?
I think that's it for tonight.
Well, thanks, guys.
Enjoy. See ya.